All right, 8.5, dot products and cross products of vectors. So this will be fun. This is dealing with our three-dimensional vectors that we learned about previously. So we're going to work with them a little bit, so let's do a dot product of u and v. I gave you u and v right here. I already set it up for us. Same story, just has one more value. So 5 times 3 is 15, plus negative 35, plus 20, equals 0. So is it orthogonal? You betcha. Orthogonal. Yes. Next, similar story. Find an angle between u and v. So I set up dot product in the numerator and the magnitude on the denominators. As such, I'm going to do inverse cosine in my calculator of negative 13 over root 21. Hey, square root of 25 is 5 times 5. Okay. If you do that, what would you get? You will get 124.6 degrees. The thing that's going to be really different about this section is something called cross products. If we have something written as this, it's read as A cross B. There's a couple things you should know about it. A cross B is a vector. Okay, so your result of it, if I ask you for the cross product, your output should be a vector. Also, A cross B is perpendicular to a plane containing vectors A and B. Why is that important? Because if I were to find the cross product of A cross B, when I go to do that, my resulting vector, if I were to do the dot product of A and A cross B, or B and A cross B, you should get 0 because they are, as a result, orthogonal. So whenever we do cross products, that's what we should get. All right, so let's find the cross product of U and V. Now, it would have been a little helpful if we talked about matrices before, but it's okay. We'll go through it anyways. So how I'm going to write this, I, J, K, it's cross product of U cross B, so I'm going to put 4, 2, and negative 1. And also, I'm going to make this point as well before I move any further. This is why it is important when we did dot products, we use dots, and cross products, we're using that, right? So symbols matter, is my point. Okay, I know we think you were taught previously that they're interchangeable because of the multiplications, but in this case, notation very much so matters. So I set it up like this. So if I am finding my first letter of our, or not letter, the first value of our vector, of course, is I, I'm going to ignore column I. I'm going to write 2, negative 1, 1, 4. And next, now the formula, be careful, because I just almost made the same mistake. Oopsies. That should be minus sign. Okay? Minus. Now, if we get a result here that's going to be negative, then also it's going to be a plus. I'm going to ignore J. 4, 5, negative 1, 4, J, plus. Now that one's plus. We got ignore K. 4, 2, 5, 1, K. Now what we are going to do is I'm going to use a different color just to emphasize this. Let's pick a fun one. Let's go red. So we are going to do this minus this. So 8 minus negative 1 will be your I. Minus, same story. We're going to get 16 minus negative 5, J. Plus 4 minus 10, K. Giving me 9I minus 21J. And that's going to get us negative 6K. I write it in component form, it'd be 9, comma, negative 21, comma, negative 6. There you have it. That would be the vector of cross product A and B. And then some questions you're going to get is prove that it is orthogonal. So what I'm going to do is I'm going to take that vector that we just found, 9, comma, negative 21, comma, negative 6, and do the dot product of this and A and this and B. So of the original, it's going to be 4, comma, 2, comma, negative 1. If I were to do that, 4 times 9 is 36, minus 42. Plus 6, is that 0? Yay, it's orthogonal. So that means what our cross product we did is correct. And let's do the other one. 9, comma, negative 21, comma, negative 6. Cross product of that. And 5, 1, 4. Let's give it a go. 5 times 9 is 45. 1 times 21 is, well, I didn't write that right. That's negative 21. 1 times negative 21 is negative 21. Minus 24 is equal to 0. There we go. I appreciate you. Thanks for watching, and I'll see you in class. Bye-bye now.